charging 400 kilometers in 5 minutes, accelerating from 0 to 100 kilometers per hour in just 2.7 seconds, a 1000-volt high-voltage platform, and 1 megawatt fast charging. These technologies, which sound like they belong in a sci-fi movie, have astonishingly appeared at BYD's latest press conference. Today, we will dive deep into the latest technologies of BYD's Super E platform and the Han L and Tang L models to uncover what has once again placed BYD at the pinnacle of global new energy vehicle technology. First, let's talk about the centerpiece of this press conference, the BYD Super E platform. In a world racing toward faster, smarter, and cleaner transportation, one automaker just changed the rules of the game. With a single announcement, they've sparked a storm of excitement, disbelief, and concern. Is this the future of electric mobility, or a high-voltage fantasy? As global giants scramble to keep pace, one company quietly pulls ahead, armed with a powerful new secret under the hood. From record-breaking performance to a bold challenge to the industry's most iconic name, something big is charging up. And it's happening faster than anyone expected. Buckle up, what you're about to discover might just flip the EV world on its head. Inside BYD's supercharging breakthrough. BYD has unveiled a groundbreaking advancement in electric vehicle, EV, charging with its new 1000 kilowatt megawatt level charging system, marking a major milestone in the EV industry. This ultra-fast charging capability allows vehicles to gain approximately 400 kilometers, 249 miles, of range in just 5 minutes, charging speeds that rival, and even exceed, the time it takes to refuel a conventional gasoline vehicle. This innovation is part of BYD's new Super E platform, which will first power 2 flagship models, the Han L sedan and Tang L SUV, both launching in April 2025. At the core of BYD's achievement is a specially engineered battery designed to handle the immense power transfer required for 5-minute charging. These new batteries feature reduced internal resistance, allowing electricity to flow more efficiently and quickly without overheating or damaging the cells. The system also leverages advanced automotive-grade silicon carbide power chips, which are known for their high thermal conductivity and efficiency at handling high voltages and currents. This technology enables the vehicle to operate on a robust 1000-volt architecture, twice the voltage of many existing EV platforms. To contend with the considerable heat built up when energy is transmitted very quickly, BYD has installed in its factories an all-liquid-cooled megawatt flash charging terminal. This cooling system, designed to ensure optimal temperature in the entire process of charging, thus guarantees the safety, reliability, and lifetime of the battery. It is very important that thermal conditions be managed, since charging a megawatt will degrade the battery with no way of cooling it or make it pose a hazard. Such BYD's thermal management solution is perhaps the most advanced so far for mass-market electric vehicles. Not only is double charging a feature in technical prowess, but it could also be a game-changer for electric vehicles. Charging time has been the most widespread concern of consumers against adopting EVs, serving as one big hurdle into electric vehicles. Making it just as convenient as refueling combustion engines will clear that hurdle of charging anxiety. If it scales and penetrates widely, it could change the whole EV infrastructure and fast-track the entire world into sustainable transportation. Though initially focused on China, it will resonate globally because it sets a different performance scale in the EV charging scope. But with great power comes intense heat, and unlocking 5-minute charging meant solving one of the most dangerous engineering challenges in the EV world. The heat factor. As electric vehicles, EVs, move toward ultra-fast charging capabilities, managing the heat generated during the process has become a critical engineering challenge. BYD's recent introduction of a 1000 kilowatt charging system, capable of delivering 400 kilometers of range in just 5 minutes, marks a major leap forward in EV convenience, but it also requires robust thermal management solutions to ensure safety and performance. Charging at this intensity generates enormous amounts of heat due to the high current and voltage flowing into the battery in such a short span of time. Without adequate cooling, this could damage the battery cells, shorten battery life, or even pose safety risks such as overheating or fire. To address this, BYD developed an all-liquid-cooled megawatt flash charging terminal specifically designed to dissipate heat efficiently during high-power charging sessions. This advanced system uses circulating liquid to regulate the temperature of both the charger and the battery during the charging process. Unlike traditional air-cooled systems, which are less effective at extreme power levels, liquid cooling allows for much faster heat transfer, keeping key components within safe operating temperatures. This is crucial for maintaining the structural integrity of the battery and preventing thermal runaway, a phenomenon where rising temperatures can lead to uncontrollable heat buildup. In addition to safety while charging, integration with this cooling technology brings along the long-term health of the battery as well. It has been found that frequent ultra-fast charging can cause the battery to degrade rapidly if not managed well, especially for high-use cases such as fleet operations or long-distance travel. Stable temperature maintained by BYD's liquid-cooled system ensures that the battery retains its capacity and performance even over the years, making charging 5 minutes feasible without compromising durability. This safeguard technology becomes a factor for consumer trust in the high-speed charging of EVs closer to refueling with gasoline for the consumers. On a macro level, this development actually paves the way for improved infrastructure for EV adoption. BYD's system sets an example of how such ultra-rapid charging stations need to be built for speed, safety, and efficiency. Finally, it provides a template for future megawatt-scale chargers, which will be absolutely indispensable as high-performance EVs become the norm. As BYD erects early markers in terms of fast being defined by low seconds to complete charging, other vehicle makers and charging providers will have to match those standards to offer the user the same refuel feel without power restrictions. It is just a matter of time before such thermal management systems like BYD's will become the deciding factor in the case of how safely and sustainably this new phase of EV technology can be deployed at scale. Grid under pressure. As electric vehicles, EVs, evolve toward faster and more powerful charging capabilities, concerns are mounting about whether existing energy infrastructure can support such rapid advancements. BYD's new 1,000 kilowatt charging system, which can deliver 400 kilometers of range in just 5 minutes, represents a significant leap forward in EV convenience, but it also presents a serious challenge for power grids worldwide. According to experts like Stephen Bragg, a partner in motor energy industry services at Pitcher Partners, this level of power demand could be overwhelming for many existing systems. Bragg described BYD's 5-minute charging technology as a big deal, but warned that the energy required to deliver that charge so quickly could create severe strain, especially in countries like Australia, where grid capacity and EV infrastructure remain limited. In practical terms, achieving 5-minute EV charging at scale would require major infrastructure upgrades, including dedicated high-capacity substations and direct power lines to charging sites. Bragg emphasized that even the current fastest chargers in Australia, which take 20 to 30 minutes to power a vehicle, are expensive and infrastructure-intensive, often costing around $1 million per unit to install. These chargers already require their own substations, so doubling or tripling the energy throughput for 5-minute charging would push costs and complexity even higher. Without these upgrades, the introduction of ultra-fast chargers could destabilize local power systems. In worst-case scenarios, plugging in a single vehicle at full speed could draw enough electricity to cause localized outages or blackouts. The matter is rendered more serious when mass adoption of the 5-minute charge is put into consideration. If there are thousands, or at the very least hundreds, of electric vehicles charging at the megawatt amperage at the same time, an immense load may be added cumulatively onto the grid. Bragg illustrated this by stating that a fast charge on a single occasion basis could drain power enough for an entire suburb in its current infrastructure. This theory is well justified. It lays bare how badly behind the grid has fallen from the pace of the innovations of EV technology. Fast charging infrastructure on a fast track is being aggressively established in China, while other countries with older or less centralized grids face steeper barriers manifested in logistics, regulatory delays, and immense capital investment for retrofitting their power systems. What that means, however, is that the impetus toward faster EV charging will not relent. Therefore, energy providers and policymakers will have to act fast. Some of the solutions to support EV charging in the future include the incorporation of renewable energy, transformer capacity upgrades, and decentralization of grid architecture. But unless long-term planning and significant investments are made, 5-minute charging may remain far-fetched for many regions. BYD has, through its innovative actions, made the transfer from what is technologically possible to what is practically sustainable. The vigor and speed of the EV revolution must now be matched by the upgrading of the energy infrastructure fueling the revolution. The race to reinvent EV charging stations. Traditional charging stations, even the most advanced ones in use today, were not designed to accommodate megawatt-level energy transfers. Most public chargers operate at 50 to 350 kilowatts, and even Tesla's latest V3 superchargers max out at 250 to 500 kilowatts. BYD's new system effectively doubles or triples that power, requiring an entirely new generation of charging equipment capable of handling massive voltage and current flows safely and reliably. To support this leap in performance, charging stations must be reimagined from the ground up. This includes the use of high-capacity power converters, advanced cooling systems, and thick, heat-resistant cables capable of sustaining megawatt-level loads without degradation. BYD's all-liquid-cooled megawatt flash charging terminal is not just a solution for battery safety, it also represents a model for how future chargers must manage thermal and electrical stress. These systems must also be modular, scalable, and efficient enough to avoid energy waste while meeting fluctuating demand. This is particularly important in dense urban environments, where space and grid capacity are limited. The development of ultra-fast charging infrastructure comes along with some new challenges to energy storage and grid balancing. Megawatt charging typically means huge sudden demands on local electricity systems when attempting to supply approximately 1,000 kilowatts to a single car in 5 minutes. In order to prevent grid saturation or even power disruptions, many of the future charging facilities will require integrated battery energy storage systems, BESS, for peak buffers. These BESS can collect off-peak electricity and supply it as needed, stabilizing usage and relieving public utilities. In regions where outside networks are weak or outdated, generally rural or remote areas, it may be the only addition necessary to make ultra-fast charging a reality. BYD's technological leap has triggered a much bigger debate within EV circles. Fast charging isn't just about what's inside the vehicles but the surrounding ecosystem as well. From urban planners designating charging corridors to the utility companies upgrading substations to manufacturers again thinking through plug standards and cooling protocols, all parts of the charging equation should change when BYD goes blasting through the country with these 1,000 kilowatt systems and thousands of fast chargers. This is admittedly setting a new benchmark in speeds. But it's actually redefining the case of what an EV charging station requires in the megawatt mobility era. This may indeed end up being the infrastructure revolution that determines just how quickly this new megawatt charging standard will become the global norm. Who builds the future of charging? As electric vehicles, EVs, become more mainstream, the battle among automakers is expanding far beyond the vehicles themselves and into the realm of infrastructure. Charging networks, once an afterthought, are now front and center in the race to dominate the global EV market. One of the most aggressive moves in this new frontier comes from BYD, which has announced plans to deploy approximately 4,000 ultra-fast charging stations across China. These chargers are designed to support its new 1,000 kilowatt megawatt level charging system, which can deliver up to 400 kilometers of range in just 5 minutes. The initiative is aimed at addressing the long-standing pain point of EV adoption, slow and inconvenient charging. For BYD, owning the infrastructure means not only enhancing the user experience but also locking in long-term brand loyalty as drivers seek reliable, fast charging access tied to a specific automaker's ecosystem. The deployment of these ultra-fast charging stations represents a major shift in how BYD is positioning itself within the global EV value chain. Historically, many EV manufacturers have relied on third-party providers for charging access, Tesla being the most prominent exception. With its proprietary supercharger network. Now, BYD is following a similar strategy, bringing charging infrastructure in-house to offer a vertically integrated experience. By controlling both the vehicles and the stations that power them, BYD can optimize the compatibility, efficiency, and safety of its charging systems, especially given the high energy demands of its new 1000 kilowatt chargers. Moreover, it reduces the company's dependency on inconsistent or slower third-party chargers, giving it a competitive edge in both consumer satisfaction and technological advancement. The contest for EV charging infrastructure is a struggle that has engaged in politics and economics. It is a clash between nations on the extent of influence they would wield in the future of mobility in terms of service offerings. Countries that want to go low on carbon emissions won't be going into any green transport initiatives that involve a huge construction of charging stations. Whomsoever saw those with the biggest and most accessible charging networks will benefit from having consumer traffic, regulatory support, and even a chunk of global market share. Against that backdrop, the building of 4,000 chargers by BYD is not only strategic in marking its establishment in China, which is the greatest EV market in the world, but also laying the groundwork for future ventures outside of China. It sends a clear cue to rivals, legacy carmakers and new EV startups alike, that BYD will lead in vehicle manufacturing as well as the energy and infrastructure systems to power them. While other companies try to close the gap, BYD, with its significant investment in early-stage build-out of charging stations, has a compelling competitive advantage. Long considered the finest in charging convenience, Tesla's network of superchargers is now facing the prospects of competition from upstarts like BYD and other Chinese industry insiders such as XPeng and NIO in multiplying further facilities for their respective users. Beyond infrastructure and innovation, there's one lingering fear holding many drivers back, and BYD may have just found the answer that could change everything. Charging anxiety no more. One of the most significant barriers to widespread electric vehicle, EV, adoption has been charging anxiety, the fear among drivers that charging an EV will take too long or leave them stranded without power. This concern has been especially prominent when compared to the quick, familiar process of refueling a gasoline car. Recognizing this issue, BYD has made reducing charging time a central focus of its technological innovation. BYD chairman and CEO Wang Chuanfu explicitly stated that the company has been pursuing a goal to make EV charging as short as the refueling time of petrol vehicles, signaling the brand's commitment to overcoming this psychological and logistical hurdle for consumers. BYD's latest solution comes in the form of a revolutionary 1000 kilowatt supercharging system capable of delivering up to 400 kilometers, about 249 miles, of range in just 5 minutes. This breakthrough, part of BYD's new Super E platform, represents a dramatic improvement over current EV charging standards. For context, Tesla's superchargers, the fastest widely deployed charging systems to date, add about 270 kilometers in 15 minutes using a 500 kilowatt charger. BYD's new technology, which doubles that speed, could effectively eliminate one of the most persistent consumer objections to EVs, that charging is inconvenient and time-consuming. This technology will have far-reaching implications. With the charging time coming close to the amount of time a typical stop at a gas station takes, the EV is looking more and more in terms of consideration toward time-strapped drivers such as long-distance commuters, road trippers, or those with scarce home charging infrastructure. BYD's development is also an answer to a broader demand in the market, where increasingly consumers are looking for convenience and efficiency alongside sustainability in their vehicles. With the introduction of ultra-fast charging in the Han L sedan and Tang L SUV, BYD is proving that it's not just making electric cars but changing the user experience around them. This breakthrough may act as a tipping point for the EV industry, especially in regions where the charging infrastructure had previously been a bottleneck. The challenges of grid readiness and the high costs of deploying such fast charging may still stand, but the very existence of an open system in mass-market vehicles changes the narrative. Consumers are no longer asking whether EVs are practical enough, but have begun to see them as entirely comparable within the context of everyday convenience to traditional vehicles. BYD's breakthrough essentially rids battery charging of all the technological limitations and paves the way to dissipate the subsequent consumer psychological hesitations, thereby giving a large thrust to the global transition towards electric mobility. The new battle for EV dominance. The electric vehicle, EV, industry has long been dominated by Tesla, but 2024 marked a pivotal year as Chinese automaker BYD surged ahead in a number of critical metrics. Most notably, BYD surpassed Tesla in annual revenue, bringing in $170 billion compared to Tesla's $155.5 billion. This shift underscores BYD's rapid evolution from a relatively low-cost EV manufacturer into a serious global contender. The company's growth has been driven by a diversified product lineup, competitive pricing, and strategic investments in battery and charging technology. BYD's ability to scale production while maintaining profitability has set it apart in a market where many players struggle to do both. This revenue lead is more than symbolic, it signals a changing of the guard in the EV space, where the narrative is no longer just about Tesla's innovation, but also about BYD's execution and expansion. Beyond top-line revenue, BYD's profitability further illustrates its upward trajectory. In the fourth quarter of 2024, the company posted a record net profit of $3.3 billion, marking a year-over-year increase of 73%. This financial performance reflects strong demand not only in its home market of China, where BYD is the undisputed EV leader, but also overseas. International shipments jumped nearly 72%, accounting for 10% of total sales and highlighting BYD's success in penetrating new markets. The company's ongoing investment in advanced battery platforms, including its game-changing 1,000 kilowatt supercharging technology, has enhanced its brand credibility and technological edge. Meanwhile, its commitment to improving vehicle quality and design has allowed BYD to shed its budget image and compete head-to-head with global luxury EV brands. BYD is climbing steadily, while the difficulties Tesla faces put pressure on its leadership. Sluggish sales are the current predicament, especially in key international markets such as the UK, where sales toppled to a shocking drop of 45% monthly. Reputationally, however, Tesla and its standing seem to say, "Hold my beer," since the growling criticism of Musk is taking center stage in this regard. The very public actions and words of Musk have ignited consumer outrage, with protests held in back of over 50 Tesla showrooms in the USA. In a few markets, Tesla owners have also debadged their vehicles, strapped on unflattering bumper stickers, or gone as far as publicly destroying their cars in symbolic showdowns. This mass cultural and brand shift, the unprecedented sight vision of Tesla, a company that literally gave birth to the EV revolution, shows how deep the cracks really are in erstwhile unshakable consumer loyalty. BYD, conversely, is exploiting the moment by executing a clear and confident growth strategy. The company is taking proactive strides in expanding its global footprint, aiming to launch its third European factory in Germany, one of the fiercest automotive markets in the world. This is a clear message from BYD, which is aspiring to become more than just a regional competitor. Its aims are to become the principal global force. In parallel, the company is integrating next-gen charging infrastructure by deploying 4,000 ultra-fast chargers across China, signaling that BYD is not just thinking cars, it's building an entire EV ecosystem. While Tesla still has a clear technological advantage in autonomous driving, BYD's unique combination of value for money, innovation, and global ambition makes it Tesla's biggest threat yet. The gridlock for the future of EVs is no longer a vision of a single company, it is a race to see which company can deliver that vision with speed, intelligence, and scale.